Okay, welcome to grade 11 college math. We are in unit 7, lesson 2. We're going to continue our learning about the quadratic relations, and this will be in the form of y equals ax squared. If we recall from last lesson that all equations with an x squared or a squared exponent are quadratic relations. So in this, we want to substitute the x values into this equation to determine our y value. So we've done this plenty of times in the past. This should be something you've seen last year. So when we substitute, we're going to take this x squared and make brackets. We're going to put the negative 4 in there. Of course, negative 4 squared is 16. So now we have a y value and an x value. So we have negative 4, 16. Okay, and actually that's the first one, but I'll give you some advice. I do like to start at the 0 and then work my way this way and work my way this way. Over many times practicing it, I find that gives us a good symmetrical idea. So that's going to be 0. So we know that it's going to be starting at 0, 0, just like this one. We're going to see if our coordinates hit these lines. All right, creating this bracket, negative 3 squared is actually 9. So negative 3 and 9. 2 squared is 4. So we have 2 and 4. And we have negative 1 squared. Oh, that should be negative 2. Is 1, negative 1 and 1. If we were to graph this, because we've hit the vertex, remember this would be the vertex, this middle point. Not always, it could be a shift, which we'll learn about in the next few days. But so let's just do this negative side. If we go over 1, then we're up 1. At negative 2, we go up 3 more to 4. And at negative 3, we go up 5. 1, 2, 3, 4, 5, up to negative 9. And I think we will be able to get the 16 up here. All right. Now in here, we have 1 squared is 1, 1, 1. 2 squared is 4. And what do we see happening here? Well, we see the numbers are repeating themselves. And that makes complete sense because a parabola is symmetrical, meaning the left side is going to look like the right side. So it's a mirror image of itself. So on this side, we have 1, 1. We have 1 and 4. 2 and 4. 3 and 9. And 4 and 16. So great. This is now this has an a value of 1. Okay, so this is a standard parabola. It forms the standard parabola in which all other parabolas are compared to. Sometimes we put, by the way, sometimes we put arrows at the top to show that. I'm just going to make a slight change to the screen here. Okay, good. Okay, so let's keep investigating and see what happens when we change the A. Okay, so we're going to make changes to the A value. So when graphing y equals ax squared when A is positive. So in all these cases, you'll notice this is a positive number, positive number, positive number, positive number. So complete each table and use different colors to sketch the graph of each parabola on the axis. So again, I'm going to start down here at the middle. I guess we'll use blue on this first one. So 0 squared is still going to be 0. And 0 times anything is going to leave us with 0. Okay. It's a little messy, isn't it? Okay, let's work our way this way then. 1/2 -1 squared. So -1 squared. So what I would say to you is what we could do is we could make this a little bit easier using our Desmos scientific calculator. So you could go and put this equation in and then use it over and over again. Let's get rid of that. No, x. And there. Okay. So what you can do is you take this, don't delete it, just copy it to the next line. Okay, using like Control C and Control V. And anyways, we can put in -1, and it will give us this answer over here. So we have 0.5. Oh. All right, come right back and change your number to 2. And we have, so here we can go right to that answer. All right. Now I remember I had a paste. Let's keep pasting this. And we go -3, and I got 4.5. And actually, by going line by line, we actually keep a record of the table, basically. We are repeating the table of values. And 4, 8. All right, so we're basically taking the square. Like, look, 16 times a half. Half of 16 is 8. And half of 9 is 4.5. And half of 4 is 2, and actually be a positive, actually. Now, we are going to double check that if we continue this pattern, a 1 here is a positive 1, we are sort of repeating the numbers. Okay, so that's good. Going. So it's definitely time consuming. Okay, at this point, we know we can repeat these numbers. So 4.5 and 8. Let's start the next one. So what if we were to take that same value and we change now, look how this next column, we're going to do a different color, and it's 1/4 now. Okay, so let's change our number here down at the bottom to 4. And so we're going to go again. Let's go top. You know, the middle is going to be 0. Anything times 0 is 0. So let's go at the top and do our -4. Look, you'll see why I did it this way. Because you're going to see, basically, 4 squared is going to be 16. 16 divided by 4 is going to give us back down to 4. All right. And we can keep going. -3, -2, -1. So let's write those in now. So going back to our -3, we have that right here. With the 2, right, it was 1. And with the 1, we're looking at a quarter. Well, that makes sense because 1 times 1/4 will be 1/4. So we can keep going. One thing we have to do is Control C will copy, Control V will paste. Now we have the quarter here. Let's change our numbers. We're going to go the opposite way now. So we have 1. That's going to be 0.25. Not a surprise that we're repeating this pattern. Okay, so I'll change that to 2. And at this point, we're pretty sure we're just repeating this pattern. And 4. Okay. Now we're going to keep going. All right, so what is the next one going to be? We're going to change our color. Let's go with green. All right, so we're going to use the same template we've been using. Now this is now a 2. All right, so there's our template we can substitute into, and we'll copy that. And so let's start at the top. -4 is 32. Replace x with a 3. 18. Replace x with a 2. We get 8. Keep going. All right. Sorry, these were negatives. Okay, let's make sure. I'll prove something to you. Whether we change those, if it's going to be squared, it won't make a difference. So we're squaring, we're making those negatives, which we should have done right from the beginning. And yeah, nothing changed. So 18, 8, now 2. We know anything times 0, 0 squared will be 0, times anything will still be 0. And we'll do a couple here just to make sure we're repeating our pattern. 2, 0, good. Well, we'll throw a 3 in there just to double check. So there we go, yeah. Pretty sure that this is going to repeat. That it does repeat our pattern. Okay, good. Now we're going to use these and punch them in, and graph them, sorry, in just a second. Let's grab one more color. Something that will stand out. Okay, we'll go with orange. All right. So here we go. We know 0 is going to give us a 0. Okay, so let's repeat our numbers. Now we have to change this one to 3. Okay, and Control C copies it. Control V pastes it. And then we go with -4, 8. Okay, paste. And we have -3 and 27. And we just keep going. -2, 12, -1, 3, and we'll save a little bit of time here. I'm very sure of it. You'd want to double check to make sure you're not going to make a mistake, but this is going to repeat itself. Okay, now this says complete the table of values using the colors. We need to graph these now. So it's going to be quite narrow. It's going to be a little bit difficult, but we'll do our best to fit it all in here. So let's start with the blue one. All right, so blue, we're going to go with 0, 0, and then you're going to go 1 and at the half. So it's going to be pretty small here, but and then you go on the other side 1 and a half, or over 1 up half. Then the next one is at -2 and -2 and 2, +2 and 2, -3 and 4 and a half. There's 5, so 1, 2, 3, 4 and a half. Wait a second. 1, 2, 3, 4 and a half. Okay, over here, over 3 and up 4 and a half. All right, -4 and 8. -4 and 8. I just want to make sure here. 1, 2, 3, 4, 5, 6, 7, 8. Good. All right, so we have a parabola going out this way. What do we notice? Well, it's a little wider than the standard parabola. All right, I'm going to show you on the graphing calculator afterwards because it becomes quite clear what happens to the parabola as you change your A value. All right, so here we go. And we're also starting at 0, 0, and this time we're going over 1 and just a quarter. It's going to be really hard to squeeze that in there. So you can see that. And over 2 up to 1. Over 2 up to 1. Okay, over 3 up 2.25 or 2.25, 2 and a quarter. So 1, 2, and just draw it just slightly over that line. That's how you do it. Okay, and then we go, keep going. So -4 and 4. -4 and 1, 2, 3, 4. Over 4, up 4. And so here you go. Now we're going a little wider, even still wider. Okay. All right, let's switch to green. All right. 0, 0, starting at 0, 0. Now our numbers change, our A numbers change to a solid whole number of 2. So we're going to go over 1, up to 1, 2. On this side also, over 1, up 2. Okay, over to 2, up 8. 2, up 8. All right, then you have over 3, up 18. I think that's where we're going to fall off the grid here. Maybe way up here. Way up here. Okay. And here you go. Now, it's hard to draw a nice smooth line, but we try our best. Okay, we got our orange color back, and we're going with a thin line. All right, so what's going to happen here? So it's 0, 0, yes, and then over 1, up 3, over 1, up 3. So we're going to see this narrowing happening. Over 2, up 12, over 2, up 12. Over 2, up 12. And then the next one will obviously fall off the grid. Okay, so there we go. Now I'm going to show you quickly what this all means. All right. So when we say that the A value is positive and the A is less than 1. So what does less than 1 mean? Less than 1 means a fraction, usually, right? A fraction or decimal. If we get a fraction like these two, what happened? They went wider, and the parabola became more open. So the way we describe this is we say, okay, well, first of all, the fact that it's positive is up. Okay, so I'm still using that orange color. Okay, so the parabola opens up, and we say it is vertically compressed. Like if you were to squash it, it gets wider because these ones are compressed because it's wider. Okay, so I would be okay with you also saying in the brackets wider. All right, now what happens when the a value is greater than 1? So remember, at 1 is standard. So anything less than 1 is wider. Anything greater than 1 will become more narrow. Now, it is still positive, so it's still opening up, and it is vertically stretched. And in this way, it becomes narrow. Okay, so look at these ones. When we had the a as a positive 2, a as a positive 3, the 2 is more narrow than the standard, and the yellow is more narrow than the green. So, and in fact, the higher the value, okay, so for this one, these two, the lower the fraction, 1/4 is a smaller number than 1/2, the wider it gets. For these two, the bigger the number, 3 is bigger than 2, the larger that a value is, the more narrow the parabola gets. Okay, so in this case, this type of transformation, now transformation is an important word, so this type of transformation, we're transforming from the standard to something a little different. So this type of transformation is called vertical compression or stretch. All right, so here we go. You can use your Desmos calculator, the graphing one, to do this. So let's say we put in the 5 equations. The 5 equations. The first one being y equals x squared. Okay, and I can actually go in and alter this. We're going to make it black so it looks like this page over here. Okay, the next one, what was the next one we did? We did y equals 1/2 x squared. And that one we used blue, so hey, that matches up. And y equals 1/4 x squared. Now we'll just change that because we used red. So let's go and change that to red. Let's keep going now on the more narrow side. Now we have 2x squared. And we used green for that. All right, y equals 3x squared. And we used red for that. So why do I? No, I didn't. Not red, yellow, or orange. Okay, now this is really cramped. But let's say I was to stretch this out for a moment. You could have a look at it. So isn't that nice looking there? Our black one is our standard. As we had, the blue had a half. It gets more wider. And for red was a quarter, which is a smaller value than the blue. The red got more wider, more compressed. As the green one went to an A of 2 and the yellow one went to an A of 3, the green one is more narrow than the black, but the yellow, because it's a higher number, gets more narrow than even the green. Okay, so I totally recommend you use the graphing calculator to help you through these questions at home. You can have this app on your phone. It's quite easy to download. Most of you have it. We'll go back to our scientific calculator for a minute, and we're going to punch these numbers in. So what's going to happen? We need a negative x, and we need to build brackets around x. Okay, so here we go. Copy that. Right, so from top to bottom, negative 4. So we have negative 4, negative 4. All right, we can do it in order if you want. So negative 4. That's not true. Negative 16. Right. Then you look at the negative 16. It must not have. Yes, that's fine. We did it right. Okay, negative 16. Okay, so negative 4 and negative 16. 16, remember, is right about 1, 2, 3, 4, 5. So the number there's 15. So 16 is right here, and it matches up with that. I'm going to change my marker to a black one so that we go color code properly. Okay, let's do the next one. So we're going to copy this, paste it, and we go negative 3, negative 9. So negative 3, negative 9. All right. 1, negative 2. Gives us negative 4, negative 2, and negative 4. Oh yeah, we said we were going to graph all these. So let's just go over 3 down to 9. Oh yeah, fits perfectly. Okay, over 2 down 4. Fits well there too. All right, let's keep going. Back to our table. You can see the tables filling in here, right? As we go through. Right, so there we go. We have negative 1. So negative 1, negative 1. And sure enough, there it is. If we do 0, we know it's going to be 0. Right? Just to prove it, right? Let's see. 0, 0, perfect. And let's do a few more. So 1, this is a negative 1. And we are repeating ourselves. 2, just negative 4. So here we go. Just keep going. We can safely assume that these are going to be the same numbers as up here. Negative 9, negative 16. Three, negative 9. Okay, so let's just double check. So that's over 1, down 1. Let's replace that number, sorry. Over 1, down to 4. This pattern, if you might notice, I'll mention in a second. Over 1, down another 5. Over 1, down. This pattern of going over 1, down 1, over 1, down 3, over 1, down 5 repeats itself. There's a pattern of 1, 3, 5. Anyways, if we had more time, we could go into that, but the pattern of 1, 3, 5 with the parabola is very common. Almost you can rely on it for sure. Okay, good. So what we're proving here is that we have a standard shape parabola, much like this one, a standard shape. What changed then? So what we have that changed was our a equals -1. So what can we figure out about when our a is -1? Well, what's changed is the negative. So the negative, okay, reflects it on the y-axis. Sorry, the x-axis. Okay, now I'm sure that's what we're going to write at the bottom, but we'll kind of summarize it. All right, let's do these numbers. I'm going to save you some time. I'll do the numbers. I'll do it all, fill it all in, and then so I'm going to skip the video so you won't see me doing all this work to save a little bit of time, okay? Okay, I'm back now. So we've completed this, and one thing we should do, and I probably should have did it to begin with, is we're going to color code these. Blue, red, green, and what did we use last time? Orange. Okay, so everyone look at these numbers carefully. Now we would use these values, and one problem you might have is that let's take this first example in the first column, 1/3 x squared. And we're going to copy that. Again, copy that, paste it. So let's take the first one, for example. If I would have put the -4 in here, all right, look what I have in the diagram, or in the table. I have -16/3. So that's really hard to graph because we don't really have what that would be. So you might want to use your calculator to make it into a decimal, because it might be a little easier to plot that. So if we go to our blue numbers, our blue table here, and we want to plot that, let's go, we'll have to shrink this a bit. Okay, so here we go. What's this going to be? So 0, 0, we're starting at 0, 0 for our vertex. We're going over 1, down 1/3. What's 1/3? Okay, right there. All right. And then we're going down over 1 and down. Okay, so you want to ask yourself, well, what's -4 and over 3? 3. Okay? So down and over 1.33. Okay, we're going over to 3 and negative 3. And last is what was, remember what 16 was? 16 over 3 was 5 and a half, 5 and a third. Over 1 and 5 and a third. 1, 2, 3, 4, 5, and a little bit. Good. Now these are going to be symmetrical, so you can do them on the other side now. 2 and 3 and wait a second. That was 1.33 on the, for we're at the 2 coordinate. Okay, so let's fix that. 1 and then we were at 3 and 3. 1, 2, 3. So it looks like we just skipped a whole number there. Okay, and at 4 we went to 5 and 1, 2, 3, 4, 5 and a third. Okay, so here we go. Make those lines symmetrical. And here's our blue curve coming out wider. Now, the common thing is that both a values are negative, so it's opening downwards. This is a pretty low fraction. 1/3 is pretty, so it's pretty wide. All right, let's get the red table of values. And so what's 1/5? Let's just see. So negative 1/5 is 20%. So 0.2. So that's less than 0.33333. So over 1 and right there, snug in between the line, the axis, and the blue. Okay, next 2 will be 4/5. Well, what's 4/5? I think we know what 4/5 are. That's 8.8. So we still haven't crossed the 1. So over 2, and then we're just going to go right before that 1. This time around, I'm going to do it symmetrically. So I'm going to go back and forth and do both, the positive and the negative side. Okay, at negative 3, well, negative 3, we're right here. 9/5. Again, kind of hard numbers to picture. So what is 9/5? Negative 1, negative 1 and 0.8. So over 3 and 1.8. That's almost 2, right? Almost 2. Over here, over 3 and negative 1.8. And finally, what is 16/5? Negative 16/5. What happened there? Do that. Negative 3.2. So over 4 and down 1, 2, 3.2. Over 4 and negative 3.2. So we see a wider parabola because 1/5 is a smaller number than 1/3. So it's wider. All right. Let's go with the green one now. So we should see something more narrow. Now, not to confuse you, but we said that fractions end up making wider ones, but that's not. So only numbers that are like less than 0. So we should have negative 3 over 2, you'll notice, is over 1. So it's 1.5. All right, so after 1, that gives us a 3.2. Oh yeah, make that a negative. So 3.2 is 1.5. So over 1, down 1.5. Might as well do it on this side while we're here. Okay, and then we have over 2, then negative 6. Over 2, negative 6. Okay, do that on both sides. And then -3 and 27/2. Let's just double check what that would be. 27/2 is 13.5. Okay, so over 3, and we're going all the way to 13. So there's 11, 12, 13.5. All right, 13.5. Okay, so we see a higher number than 1 turns into a more narrow line. And finally, let's do our orange. Okay, so starting at 0, 0, we're going to get nice even numbers finally because we have a nice even number here. So 0, 0, and then we have -1 and -2. -2, -8. So -2, -8. Let's do both sides while we're at it. Okay, -3, -18. -3, -18 actually falls off because this is 15. Oh, wait a second. If that's 15, 16, 17, 18 right here. Okay, now it's going to be tight to draw this, but take a look at that. Try and make it more curvy. It's difficult with this touchscreen laptop with the pen. Doesn't work out all that smoothly. All right, and so if we were to go over here, and I was going to punch all these in, so y equals negative x squared. Right? There's our standard shape. We're going to again turn that to black. All right, and let's see what that's going to look like. So we're going to give ourselves 4 lines. Copy, copy, copy. 1, 2, 3, 4. One more. And we'll alter our colors. See how I'm doing that, so feel free to do that when you're working these out. We'll go with our red one, then our green one, and then our orange one. Okay, so what was the blue? All we have to do is change the A number, the A value in front. 1/3. There it is. Now it popped in. The blue one's a little bit wider. 1/5. Okay. Oh, something, now the X is missing. So X, good. So the red is wider. Good, neat. Okay, now we put 3/2, and we get a more narrow green line. And again, I'll make this more clear. Here we have 2. All right, so here we are. Remember what you see right here, and we're going to go and get the keyboard out of the way. And so yeah, it's a mirror image of the one on top. And it's just that when we have a negative, actually, they're not a mirror image. Some of these numbers are a little different, right? So the numbers are a bit different. But what we see is when it's a fraction between 0 or 1 for A, it goes wider. When we see a number higher than 1, it goes narrower. Right. So to summarize, we can write this. When the number is a less than 1, okay, then it opens down. When the number is negative, when it's negative, the parabola opens down. And in this case, when it's less than 1, it is compressed. Similar to the first example. Okay, when it's negative, it's opening down. And when it's greater than 1, it is stretched. Okay, so when a is negative, this type of transformation is called a reflection. In the x-axis. Reflection, like a mirror, right? And it's basically flipped. I'm going to just change what I just did there, just to give myself the x-axis. And think of it as being flipped. All right, so this is actually part 1 of, it's quite long, but it's not a difficult concept. It's just long to fill in all our tables. But this is actually the first part of lesson 2, a bigger lesson 2. Okay, we're continuing with part 2 of lesson 2. It's a continuation in our chapter 4.2 section. We see that it covers the basic parabola shape, which is given the equation, the standard equation of y equals ax squared, where a equals 1. So in this new part of the note, we see that we've added something here, a k. Okay, and this, we're going to see what k does to make a change. All right. So over here is our table. We're going to graph this when k is positive. So we have a plus k. Complete the table of values. Use different color to sketch your graphs. So we're going to go through this hopefully quickly. We're going to add a k to our standard over here in the graphing calculator. So Control C, Control E to paste. We're going to put in x values, and our k in this first example is 2. We might as well do it with a color. You know what else we're going to do? We're going to put the standard one in there. So we have something to compare it to. E squared. Good. All right, we're going to move that up. Let's go with color changes with black. Okay, and we can do the red one here. Okay, so if we take our first example here, and we repeat ourselves. No, we have to go over here, right, to our. So we're going to use this as our equation that's in our table, and we're going to quickly go through and change the number for x. So x is going to change, so that would be like saying -4 squared plus 2. Of course, -4 squared is going to be 16. 16 plus 2 is 18. Okay? We could maybe do this in our head pretty quickly. -3 squared is 9. 9 plus 2 is 11. This might be faster. -2 squared is 4. 4 plus 2 is 6. -1 squared is 1. Plus 2 is 3. 0 squared is 0 plus 2 equals 2. And 1 squared is 1 plus 2 is 1. and our pattern, sorry, is 3. 1 plus 2 is 3. Our pattern is going to repeat itself. So we're going to have 6, 11, 18. So yeah, maybe that's faster than using our calculator over here. But again, you got to be strong in algebra and all these courses we take. So what happened with the plus 2? Right? It's almost going to raise, have the effect of raising it. So look at 0 plus 2. There we go. At negative 1, we're going up to 3. At negative 2, we're going up to 6. At negative 3, we're going up to 11. Oh, that might be 10, eh? 1, 2, 3, 4, 5. Oh, it's always just underneath, so yeah, I'm good there. And if that's 15, this is 15, 16, 17, 18, around up here somewhere. We don't have to. Well, it's on this line, isn't it? No, it's going to be ahead of that line. Okay, here we're going over and up. So over 1, up to 3, over to 2, up to 6, over to 3, up to 11, and over to 4, up to 18. Oh, missed that line. It's tricky with this smartboard pen. All right, good. So what happens? What does it look like when you do it on here? Well, it did it for us, didn't it? It's right there, that red one. Okay, so let's pick, let's see what this is going to look like. And a green one, let's say. All right, so we're going to get negative 4 squared is 16, plus 4 is 20. Negative 3 squared is 9, plus 4 is 13. Negative 2 squared is 4, plus 4 is 8. 1 plus 4 is 5. 0 plus 4 is 4. And now we're going to repeat the numbers. We've had enough experience now to know that that's what's going to happen. Okay, 0, 4. 1, 2, 3, 4. Okay, we have negative 1, 5. Negative 3 and 13. Yeah, this is 10. 11, 12, 13. And the next one will fall off the grid. So make these over 1 up. I think I missed something there. Sorry, guys. At 3, we're going, no, at negative 2, we're at 8. So if that's, and then up to 13. 1, 2, 3, 4, 5. There, that's better. Okay, over and up, over and up. Okay, good. Let's double check that and confirm it with here. What that's going to look like is y equals x squared plus 4. So it's hard to tell, so let's take a closer look at that. Okay, so definitely looks like what we've done is, so what does changing the k do here? Well, we've moved up 2 grid lines and 4 grid lines, but the rest of the shape is the same because the a value is still 1, and this is 1, and this is 1, and this is 1. So the only thing that's only thing that's changed is we moved our y-intercept up. and our vertex also moves. So it's our vertex that has moved up 2 units. Let's take a look at when this changes to a negative number. But anyways, 16 minus 3 is going to be 13. Let's change our color here. We haven't done a blue one yet. Okay, 9 minus 3 is 6. 4 minus 3 is 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. And then we're going to repeat our numbers. Okay, so here we go. We're starting now at 0, negative 3. So look, this has everything to do with where we start with. Negative 3. 1, 2, 3. There we go. At negative 1, we're going to negative 2. Negative 2, we're going to 1. Sorry, my mistake. We're going negative 1, negative 2. That means upwards. Negative 2, we're going up to 1 now. Negative 3, we're going up to 6. And then next time we'd be off the grid. So do the symmetrical side. And there we have. So it has the same shape. It's just the starting point is lower. Oh boy. It's a little off, isn't it? Okay. Oh, I hit a bump or something every time I do it. All right. We'll look at it nicer when we get a chance. All right. What happens when we keep going? So we used orange before, worked nicely. Let's do that again. So 16 minus 5. I'm just going to fill these in. 9 minus, because these numbers are going to stay the same. The first one. Okay, so 16 minus 5 is 11. 9 minus 5 is 4. Negative 1. Negative 4. Negative 5. And then repeat. Negative 4. Negative 5. 4. We missed 1 somewhere. Sorry, negative 1. Because that's a 4. I guess I had it written messy. And negative 11. So what do we have here? We have 0 starts at negative 5. 1, 2, 3, 4, 5. Something's wrong here. 1, 2, 3, 4, 5. Okay. 1 further down. Okay. Negative 1, negative 4. Negative 2, negative 1. Negative 3 and 4. 1, 2, 3. Again, I really messed up that blue line, didn't I? So anyways, just ignore the fact that it's touching the blue line. The blue line should be more narrow. Over 1, or sorry, it shouldn't be bumping into that spot. All right. So what we should be seeing is that the shape is the same, but it's where it starts. It's been shifted. Okay, so if we go over here, new numbers in, I have still x squared, but I have a minus 3. All right. And here I have a minus 5. Now, what colors did we use here? Color code to blue. This one should be blue. This one should be, it was green before. All right, and then this one should be orange. All right, again, difficult to see it all. So let's stretch that out. So we see as the K has changed, basically it's changed this starting point. We started with a K of 0. We started at 0, 0. And 2 moved it up 2. 4 moved it up 4. Negative 3 moved it down 3. Negative 5 moved it down 5. So the shape is the same. These do look wider, but it's because we're seeing more of it. Eventually, if you were to go up and up and up, look how close they get. They almost become the same line. Okay, so kind of cool. Parabolas go off into space for as long as they can. How do the graphs of x squared minus 3 and x squared minus 5 differ from the straight graph? They are same graph, only shifted down. Okay, what else do we know? Well, we know that the value of k determines the vertical position, and that it shifts up and down. So let's see if we can make it. So in summary, the k determines the vertical position of the parabola. If k is positive, the parabola shifts up the k number of units. So if k is 3, then it moves 3 units. If k is 5 or negative 5, it's 5 units. If it's negative, it shifts down. Okay, so I hope that's crystal clear for you now.